Hi, I'm John Dorelli. I'm a space scientist at NASA's Goddard Space Flight Center. I'd like to tell you a little bit about NASA's MMS mission. MMS was designed to study a phenomenon known as magnetic reconnection, which is kind of a magnetic explosion in space. You can think of Earth as a giant bar magnet with magnetic lines of force emanating out into space in a dipole pattern. Under just the right conditions, energy in this magnetic field is explosively converted into plasma energy, creating spectacular space weather phenomena like the aurora and magnetic storms. To catch these explosions in action, the MMS orbits were designed in two phases, a dayside phase and a nightside phase. MMS is actually 4 identical spacecraft flying in a geometrical formation known as a tetrahedron. Scientists hope to catch the magnetic explosions somewhere inside this tetrahedron. At closest approach to Earth, the tetrahedron is highly stretched and not suitable for capturing the magnetic explosions. But by the time we get out to 76,000 kilometers, MMS will be a nearly perfect formation, with the 4 spacecraft separated by only 10 kilometers. The Sun is constantly blowing out its atmosphere into space, and this solar wind meets Earth's magnetic field at the magnetopause. Here, at the magnetopause, scientists expect to catch magnetic reconnection in action. So the apogee of the orbit is designed so that the tetrahedron cuts across the boundary twice per orbit, while in perfect formation. As it crosses the magnetopause, MMS will take high-speed snapshots of the magnetic explosions as they unfold.
Throughout the universe, there are forces fundamental to how things move. Just as gravity is key to how things move on Earth, a process called magnetic reconnection is key to how charged particles speed through space. The more we understand how those particles are accelerated, the better we can protect our spacecraft and astronauts as we explore deeper into the solar system. And now, NASA's Magnetospheric Multiscale Spacecraft, or MMS, has discovered magnetic reconnection occurring in a new and surprising way near Earth. Typically, images of our planet from space show a blue-green sphere engulfed by the darkness of space. But invisible to the eye, a vast network of magnetic energy and particles surround our planet. Earth's magnetic field creates a protective bubble that shields us from highly energetic particles that stream in both from the Sun and interstellar space. As the solar wind bathes our planet, Earth's magnetic field lines absorbs this energy and get stretched. And like elastic bands, they eventually release energy by snapping. As a result, particles in the region are flung at supersonic speeds. That burst of energy is magnetic reconnection. It's pervasive in the universe. It happens on the Sun, around Earth, and flings particles across the solar system. Scientists have observed this phenomenon many times in the magnetosphere, Earth's vast magnetic environment. Now in a new study, MMS caught the process occurring in a new region. For the first time, magnetic reconnection was detected in the turbulent magnetosheath, the boundary between the magnetosphere and solar wind. This region is made up of turbulent plasma. It's one of the most chaotic regions in the near-Earth space. MMS captured 3D observations by flying 4 identical spacecraft in a tight pyramid formation through the magnetosheath. These arrows show the hundreds of observations MMS took to measure the changes in particles and the magnetic field. This is the moment MMS sees bursts of energy from magnetic reconnection. But these signatures don't look like standard reconnection. Compared to standard reconnection that occurs over tens of thousands of miles, this new magnetic reconnection spans only a couple of miles within turbulent plasma. These reactions are essentially much smaller but more stretchy elastic bands that accelerate particles 40 times faster. In short, MMS spotted a completely new magnetic mechanism that's much quicker than we've seen before. Just like when you mix milk into coffee, turbulent plasma in space moves randomly and creates vortices. It can transport particles and energy, but a lot is unknown about how these particles move through these regions. Showing that this new magnetic reconnection plays a role in turbulent plasma gives scientists insights into how turbulence influences particles moving through space. By looking at such fundamental processes in space at both large and small scales, scientists can learn what drives the complex environments we travel through to explore our solar system and beyond. As Parker entered the corona, its whisper instrument took these images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. Here we see distinct cells. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle though. Exactly how they form is still unknown.
Space radiation is a mix of high-energy, heavy-charged particles that originate from the sun. To put things in perspective, 1 year of Earth exposure to cosmic rays is equivalent with 1 day of space radiation exposure in deep space.
Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
We say this is a beautiful image that you see. What you see here, this one, is a human cell. This is a human nucleus, so it's 10 microns approximately. And these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space, but not on Earth, except in Darmstadt, the GSI, where we have it, going through the cells and making damage to the DNA. So it's a big problem. You will not solve the problem using passive shielding. You can think of active shielding. You can think of electrostatic shielding. I mean, some kind of electrostatic spheres that protect the astronauts. Radiation is a problem, this is clear. Shielding, passive shielding, can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea, is to use a magnetic shielding, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now? Okay, maybe I can make a magnetic field,
We have been working in low Earth orbit for a long time, for which we have technology, which is a material technology, material shielding. They call sometimes passive shielding also. But then if you leave low Earth orbit, we don't have technology for that. But then if you leave low Earth orbit, we don't have technology for that.
The staging from the lunar surface really doesn't make any sense because it's different technology to land on the moon. The moon doesn't have an atmosphere. So you'd have to develop all these technologies specifically to land on the moon because, frankly, all those things we developed for Apollo are basically gone at this point. We'd have to sort of start all over again. So that's a whole lot of money.
Oh, that's hilarious.
They close down the sound stage.
Exactly.